This handout is about recoil and conservation of momentum. Recoil is where two objects are pushed apart. They begin at rest and are pushed apart, like a cannonball and a cannon. We've got a Civil War cannon. The cannon weighs or has a mass of 875 kilograms. The cannonball is much less, it's 35 kilograms. And when the cannonball is fired, it gets a velocity of 145 meters per second, and it's shot at an angle of 35 degrees, and the length of the barrel is this much. What is the recoil velocity of the cannon? Recoil velocity is the velocity that the cannon has when it goes backwards after it's fired. The cannonball goes forward, the cannon goes backwards. That's the action reaction. The cannon going backwards is called recoil. Um, the cannon exerts a force on the cannonball, and the cannonball exerts a force on the cannon. That's the action reaction. This is a third law action reaction pair. But what we know is in any interaction, um, the total momentum before the cannon has a momentum, the cannonball has a momentum. The total momentum before equals the total momentum after. Since the cannon is at rest and the cannonball is at rest, the total momentum before is zero. Then the cannon is fired and it's got a momentum. Let's see, the cannon has a mass of 875. It has a velocity, we don't know it, so we just call it V. The cannonball is 35 kilograms. Its velocity is 145 meters per second. And to solve for V, we subtract 875 from both sides. Equals 35 times 145 is 5075 kilogram meters per second. Divide both sides by negative 875, and you'll find the velocity. That is kilograms, of course. And you get a velocity of negative 5.80 meters per second. The cannon, once you call the cannonball's velocity positive, you have to expect that the cannon is going to have a negative velocity because it's in the opposite direction. We're going to skip C and we're going to go to D. What is the momentum of the cannonball at the top of its trajectory? So at the peak of every projectile, Vy equals 0, and Vx is the only. In order to find the momentum at the peak, you have to find Vx because there is no Vy. What we also know that for any projectile, Vx is constant. There's no force in the horizontal direction, Vx is constant. So if I find the initial Vx using trig, I'll know the Vx at the peak. So the V is 145 in the beginning, and the angle is 35 degrees. So that's cosine. And let's see, 35 cosine times 145 equals 118.777 meters per second. And now we find the momentum at the peak. So the mass of the cannonball is 35 kilograms. Its velocity in the beginning was 118.77. So that means that its velocity at the peak was also 118.777. And you get a momentum of 4160 kilogram meters per second. You multiply the numbers, you multiply the units. Okay, a ball, 0.15 kilograms, mass, thrown with a speed, there's your V. It's hit straight back. We've done this problem before. This is, since it's hit straight back, This velocity is negative 22 meters per second. What is the impulse? So J equals Ft. Impulse is force multiplied by contact time is m delta v. We're obviously going to use this. J equals m delta v. So impulse, because we have a mass, 0.15 kg. We have a change in velocity, that's Vf minus Vi. Now 0.15 kg. The final is negative 22.0 meters per second because it goes in the opposite direction. The initial is 20.0 meters per second. That's a negative 42 change. 0.15 kg times negative 42 meters per second gives you a momentum, an impulse rather, of 6.3 kilogram meters per second. Multiply the numbers, multiply the units. 0.15 times, this is negative, not point. Actually, wait a second. Yeah, this is a negative value, isn't it? Let's take a look. Yep, I left out the negative. Let's say 0.15 kilogram. Yeah, speed, the finals. Yep, negative. It's negative 6.3. Okay, find the force. Find the force. It's F. If you've got an impulse, a contact time T, so J equals Ft equals m delta V. We have the impulse from before, negative 6.3 kilogram meters per second. We need an F. We have given a T, 2.0 times 10 to the negative 3 seconds. And you divide both sides by this number, divide both sides by the time, and you get this force, this negative force. You expect a negative force, right, would send it back in the opposite direction. If you call the 20 positive, it's going to be sent in the opposite direction, so by a negative force. Railroad car with the following mass, following velocity, collides and couples, joins and combines with two couple cars. Each couple car has the same mass as that single car that's moving at 1.2 meters per second. So what is the speed of the couple car? All right, so you've got this is 20,000 kilograms. So total momentum before equals total momentum after. It's a collision problem. It's 3.00 meters per second. That's its momentum. Now the two cars are just as same mass as this. I'm going to combine them two and find their combined momentum, even though they're not joined. But rather than do it twice, I'll just do it once. Each car is 20,000, and we're also told it has a velocity of 1.2 meters per second, and that's the total momentum before. They combine, all three of these cars combine. They become 60,000 with a velocity we don't know. This single car is 60,000 kilogram meters per second. I got kilogram meters per second plus 40,000. This is 48,000 kilogram meters per second equals 60,000. The three coupled cars times this velocity we don't know, so it's 108,000 kilogram meters per second equals 60,000 kilograms times V. Divide both sides by 60,000 to isolate the V, and you get the following answer. And that is it. Did you follow that? We had a single car, 20,000 kilograms with a speed of 3 meters per second. We had two cars that were 20, and they both had the same velocity. So I just wanted to find their momentum, so I just added both masses. They both had the same speed, 20,000 times 1.2. I could have done 20,000 times 1.2 and another 20,000 times 1.2, but I combined the masses and multiplied by their velocity. They all coupled together, all three cars that were 20,000 coupled together to become 60,000 with a single velocity. I added up the total momentum before, which is 108,000, and the three masses, 20, 20, 20, became 60,000 times V, divided both sides by 60,000 and got that answer. And that is it.